if x is approaching 3 from the right, those values are greater than 3. Therefore, x minus 3 is greater than or equal to 0. Positive. The absolute value of x minus 3 will be equal to x minus 3. Now, x can be 3, x different from 3. The limit as x approaches 3 from the right of x minus 3 over the absolute value of x minus 3 will be equal to x minus 3 divided by x minus 3, which is 1. Remember, x is not defined as 3, so it's going to be an empty circle. And we have the line y equal to 1 as the graph of the function on the right side of 3. If x is approaching 3 from the left, those values are less than 3. Therefore, x minus 3 will be negative, and the absolute value of a negative number is equal to its opposite. So the absolute value of x minus 3 will be equal to minus parenthesis x minus 3, which represent the opposite of x minus 3. Now, x cannot be 3. The limit as x approaches 3 minus of x minus 3 divided by the absolute value of x minus 3 will be equal to x minus 3 divided by minus parenthesis x minus 3, and it's equal to negative 1. X is not defined as 3, empty circle, and we're going to go left, and the line y equal to negative 1 is the graph of the function to the left of 3. So the left limit is different from the right limit. We say that the function does not have a limit. For 9, we're going to try direct substitution. So we'll take f of 0, which is 0 divided by 10, 0. 10, 0 equal to sine 0 over cosine 0, which is 0 over 1, which is 0. Replacing 10, 0 by its value, we're going to have f of 0 equal to 0 over 0. And indeterminate form. X over tangent x means we're going to divide x by tangent x. Tangent x is sine x over cosine x. Division is the same as multiplication by the reciprocal, so we multiply by cosine x sine x, which can be written as x over sine x multiplied by cosine x. Now, we're going to flip and take the inverse of the first factor. So it's 1 over, we flip sine x over x, which means the same as x over sine x, multiplied by cosine x. Now we can take the limit. We're going to search for the limit of 1 over sine x over x as x approaches 0, multiplied by the limit of cosine x as x approaches 0. The limit of a quotient is equal to the quotient of limit, so it's the limit of 1 as x approaches 0 over the limit of sine x over x as x approaches 0, multiplied by the limit of cosine x as x approaches 0. As x approaches 0, the limit of 1 is 1, and the limit of sine x over x is also 1. Limit of cosine x is 1. 1 times 1 is 1, and we're done.